So, good morning. So today we are going to do raster file creation. Now, basically, what we want to do is how to create raster file, because most of the times they are already existing. Maybe we have the digital elevation model that we download online, but today we are basically going to be doing it from scratch. But first, I know you've already been able to learn how to do that from the Google site, as you've been able to uh, match this up. Let me, like a refresher. So you've been able to do those lines on Google Earth, and then you'll be able to go to GPX Global Visualizer. So with all of that, we will just build on what you've done. All right. So uh, from here now, we just build on what you've done, and then so we're going to be opening exercise 9. So this is our exercise 9. It's actually the B part of the exercise, so we'll just drop it. So this is as a result of the same procedure you've done before, previously. And so we're going to use this to create some sort of file and all that. So now what we want to do is we want to do interpolation. Okay? So first, to interpolate, you need X, Y, Z. And Z does not necessarily mean height or elevation. Z can be, which is the third dimension, it can be as a result of measured temperature of a location. It can be the weight of calcium, aluminum, different thing can be soil, it can be anything that has a value. So you interpolate. And in interpolation, we have interpolation and extrapolation. Interpolation is within the area. Extrapolation is outside the area. Meaning, we have this point here, right? We can interpolate, which will give us value approximate around here that will create a raster. If we extrapolate, let's say this is area, we can, from this small ABU point we have, we can extrapolate to the whole of Sabongari local government. That is extrapolation. So those are the tasks we'll be doing on this exercise. So first, we want to interpolate this point. And to do that, you either go to a search button. I easily use search because if you know the tool you're looking for, you won't have to go and be clicking until you get there. So we just search for IDW. Cancel that and start. Just search. Yes, just cancel that for now. We'll do it later. So you go to your search and you search for IDW. Yeah, so you enter. So we have 3 IDW. We have IDW 3D analyst, IDW spatial analyst, IDW geostatistical. I preferly use the geostatistical, but the IDW spatial and geostatistical will do a great job. All right. So they do the same tasks, but they are not. They have different this thing. Now, if you look, they said interpolate a raster surface from point. If you read the from point, this one say uses the measured value surrounding. You can right click and check information so that you can read everything on it. Okay, so let's check the information. Just click on this, the measured distance. So you say uses the measured value surrounding the prediction location to predict a value for any So it uses the measured value surrounding the prediction. You can read it from your own. Surround the prediction location to predict a value for any unsampled location based on the assumption that things are close to one another and more alike than those that are farther away. This is the what's it called, theory of geography or something by somebody, I've forgotten his name, that he believes things near things are closer than other, something like that. I've forgotten the whole theory of geography, all of that, but it's this one is predicting more on the theory of geography. I've forgotten the name of the man, but if I remember, I'll bring it up. So now from your search, let's use the geostat. Just click on the cancel that. So click on the geostatistical. No, just click. Okay, so the input file will be your data, right? Now, if you check the Z value now, you click on that ID and take it to heights. We have heights in the values. So you take it to height. Then they're asking you for output raster. So that's where you want to save the raster now. So you click on the folder, not this next one. Yes, click on that folder. So just save it, abu.tif. abu dot that's the folder you kept it. You have to go back like this. You select where you want it to be. So you can put it here. So put abu.tif. Okay, so next is that you will go to environment. But this time around, we don't have anything. So let's just click. If we have, well, let's go. Just click OK. Don't need to do it. Just click OK. So do you see? If you check our result, they are the same thing. Just that the color RAM is a bit different. But if you check the result, we have the same thing. Now, if you look at the value, these are actually the lowest part of it. This blue, which is 639. The higher, the red one is 662. So it's interpolated based on that. You understand? So if we have a point, let's say a polygon around here, and we want it to just cover the polygon, that's when we'll go to that other side. But we'll look at that subsequently, all right? So do you understand? This is how you can interpolate. Now, based on what, let's use the other one, which is this one. Let's use the normal one. No, the first, the IDW itself. Up. No. Yes, this the way your mouse is, click on it. So bring in the data again.
Now is the data that I interpret before or
Yes, still the data interpolate. So you change, no, don't worry, just change this thing to height. Yes, then change the location now, maybe make it, don't, just, it's on the default, so you're going to where you can save it. So put ABU1 now. ABU1.tif. Save. Then okay. Now look at it, we still have the same result. Just that the color are different, but you can see if you check the previous and it's the same result, isn't it? Is it not?
the first one was the higher value was 63.
662, all of them. Okay, the first, okay, 663, yes. But it's just an interpolation, just a section of a curtain or something like that. You can see there is 63 to 65, which is this one is 62 to 65. At the end of the day, it's just approximately almost the same thing. Yeah. So let's try the cricket as we give you a tough time. Cricket. You need to spell your cricket well. It's Cree. Then G. ING. So the Kriegen, this one, the spatial analyst, you click on it, bring in the data again. Now if you check the sampling, that the Kriegen one is a bit different from the other one. It has no, so you just, right, then you go to where you save it, ABU3 now. BU3. Oh, 2, sorry. 2. Now look at, okay, save and then, no, you have to save first. Now look at, you will see up, you will see Kriegen method. We have ordinary, and also under ordinary we have semivariant model, we have spherical, circular, exponential, and all of that. So anyone you choose, it's fine. You can, if you come under universal, we also have some other this thing. So anyone you choose, I mean, I almost go with the default as a spherical. If you want to choose circular, exponential, Gaussian, let's try Gaussian and see. So change it to Gaussian under the ordinary. Then click on OK. You can see that the result is almost still the same thing. So we've used how many methods? We used 3 methods, interpolating method, but at the end, we're still getting almost the same result, isn't it? It's okay. So we've done interpolation, isn't it? Now we want to do extrapolation using the same data, assuming that this is the boundary. We only have, look here. We only have data for this point. These are the only points that we have data for. As we have x, y, and z of only this x, y, and z. Do you get? But only for this point. We don't have for this point. And we want to extrapolate such that we will have elevation of this point. That is the purpose of, that's what we call extrapolation, right? So that's what we're going to do here. So now we'll go back to the search tool and we're going to pick, let's go to IDW now. Pick the geostatistical. It's not that you only be using IDW, you can use any of them. That's my preferred tools. Yes, you can use any of them. So the geostatistical. So you click on it. Now you select your input, which is the point. The data, yes. Then you select the third dimension, which is your height. Then you save it, let's say extrapolation folder, then you want to save it. Yes, you can save it as extrapolation. Yes. It's a raster, so TIF. Yes, it's safe. No, okay, oh, no, okay, no. We're extrapolating, so they're a bit tricky. So now click on environment. We started it yesterday. Now on processing extent, change it to the boundary line. Same as layer boundary. Click on the default. Click on it. So you see same as boundary, same layer as boundary. Same now, what this means is that you want it. It's not that you'll be looking for this thing. Sometimes it will not be this. All you are trying to say is that you're trying to tell this thing is that okay, it should use the boundary. Your boundary can have another name. This is what we're talking about. She does your own, you put boundary, mine I put BD. So you are telling it that you should use this place to extrapolate. That's why I say same as layer. Sometimes if you put the name as building, it will be same as layer building. So any name you save, that's what it will be. Now go down to raster analysis. Raster analysis. You're there? Scroll down. Keep going. So now on the marks, you do the same thing on the marks. Use the
Mass or max?
the down one, your marks. So click on it and take it to boundary. So now click on OK. Yeah, okay. Let's hope it works. Your one did not do redo it again. My own did. See my own. So did you now see? It stretches the point. It uses it and say, okay, let's assume until we have something that covers. Now this is why you see some people will have a data and make sure that it covers their boundary. So this is how you use it. So we see we extrapolated to cover the entire boundary. We only have points for this area. I think I know why your own did not do.
Okay.
You have not saved editing. Write the name again. Extrapolation, sorry.
Dot G.
Go down to environment. Processing extent. Yeah. Okay. So let's watch. Uh-uh. What happened? Let me try it again. So look at, just watch. I'm using the other one. I'm not even using the first one. So data, right? I don't think I did anything special, but I don't know why else it's not doing. So I will leave it at default layer. Just go. This is all I did. This is all I did. Didn't do anything special.
happened?
I don't know. See, mine also did. It did again. No.
Let me remove those ones.
Which one? No, it's not by those ones. See now, this one also did. Now all my ones are here now. All the ones we've been using, they're all here. Try it again one more time. Let's see. Okay. So we want to create our own digital elevation model. So first, to create a digital elevation from survey, you need to bring in the X and Y, right? So that's what we want to do. So there is a data called ecology data, which I've given you. So you click on file now. Let's go to file. No, just leave it there. Go to file. Then go down to add data. Then add XY data. Click on add XY data. So click on the folder. Have you done that? So navigate to where you save the ecology data. Where did you put it? And to look for it. You're no longer in your work now.
Yes.
Train. So this is it, yeah? You add it. Now, once you've added it, under XY field, change it to easting. The X is easting. Yes, change what is there to easting. And change the Y to northern. Then the Z to height. And then you click on OK, because we already have a coordinate system, right? So there's no need changing it. So we can change it because this is in Minat zone 32. We can just change it to Minat zone 32, which will differ from change it to Minat 32 under edit. Yes. Minat zone 32. So you click on OK. Now it's going to come in a different coordinate system. So this will not have the same coordinates as the first one. Yes, OK. So you see that the ecology data has come. But now it's coming as an event layer. So you right click on it. Yes, right click on the ecology. Then go to data. Export data. So save it in a work folder. So we can call it data or ecology data. Just save it. Now it's going to come as a future class or a shapefile, anyone. Ecology, call it. Just leave it like that. Something you understand, not necessarily it must. So you click on save, and then you click on OK. So it's going to export, export it, and then let you know. Yes, click yes. So you remove the event layer. No, the event layer is the up one. No, which one? No. This one is the event layer. So we remove it. Now, do you see how we bring in the Excel file into this? Isn't it? So next, what we want to do, like I said, we also want to create a digital elevation model, right? So the next thing we want to do from here, after we've import our survey file, is to go to this and search for TIN. TIN. Have you searched for it? TIN, not TIM. Then pick any of them. Interpolate it. No, yeah, just drag it and draw. Interpolate it. You've not saved this thing now. Always remember, anything you see green, this green, you must provide the detail. So let's just do like this. We still have those previous ones, but I just want us to create another one. Alright, so from here now, this is what we're going to use to create our tin. So tin are created from either any of this interpolation, right? So now you go to your search again and search for tin now. So pick the tin, pick this one, the one that has this create tin, pick it. Then output tin. You can just say TIN. Come in. Alright, so if you check it, so did you see the tin? It created the tin. If you look at now, this is different, it's in different distance, but if you look at it, you will know that. Let's look at what's happening here so that we'll know whether what we did is. See, these green ones are actually low, even up to this one. They are the lowlands. So the tin now proves to us that what is created, the lowlands. Did you see? Do you understand what I just did? Go back to the tin. To create the tin, the first one is the output. Click on, create tin. No, the output is the first thing. We decided to use the default folder, or we use that's the output. The input now is this data we have here. Any of this is the input. Then you click on OK. That's how to create the tin. You can also tell it to contain constrained linear, but it's optional. So once you've put once you put anything here as the name, and then we'll click on OK, it's going to create a tin. And there's another one already existing there. But do you understand? And that's how to create a tin. And the tin is, what it means is that it's a triangulated irregular network. So it's a series of triangles that they use in triangulating to get this. So with this, you can easily get what they call it. Can easily get your DEM from it. So now to continue, you go back to the search now. You will see tin to raster. So click on it down. Tin to raster. So you bring in your tin now. That's the tin now you bring in. And then, yes. So you have to put it raster, or just put DEM. So you click on save and OK. Now, do this look to you like a digital elevation model, the one you download online? like SRTM and any of them. So this is how you can use your survey point to create a high resolution digital elevation model. From here, you can still make it colorful by going to properties. Then you can do quite a lot with it. So that is all you can do. You come to symbology, you go to classify, and then you classify into 5 classes, give it a color of your choice. Then we can put this hue effect. Boom. You see. This, if anybody see this, they could think we download it online, but we generated this. Do you understand? So this is the whole about module 9. Okay? Any question? Now we've created them in module 9. Module 10, we will be using them. Do you understand? In module 10, we'll be using them to do all the things we've been doing so far. So module 10 is actually raster production. So, but you need to understand how to generate and create raster for yourself. Are we together? Any question?
The problem is that from the ID, the one that I did, I couldn't solve.
No problem. You will get it when you keep practicing. But I know you understand the steps. So whatever is the issue, I'm here for a question. But just practice it first. But I don't know why yours is. I know if you do it here, it will do. I don't know what's wrong with your system. But that is not an issue. It's not as less you keep trying. I believe it will do. Okay. So that is all for today. We'll see you tomorrow.